Hello, how are you all? Thanks for showing up. So I'll be doing a talk on Azure IaaS platform security and do a deep dive. So as an introduction, I'm Vikas Bhatia, and I lead Azure Compute Security as well as confidential computing. And my colleague, Mario Lopez, will join me in a few minutes from the Azure networking team. So let's get started. What we'll cover today is we'll walk you through an end-to-end approach of security. How do we help you protect your identities, your apps, your workloads, your networks, your compute, your storage, while enabling compliance and innovation? So what we'll do is first, we'll cover how do we think about Azure security to secure your digital assets. We'll talk about defense in depth approach. As we all know, security is never 100%. It's always about adding layers. And then we deep dive into different areas, such as key management, compute, storage, and networking. So let's get started. So as I mentioned, security is multi-layered. We have engineered security into every layer of the stack, whether that is an adaptive network protection, whether that's end-to-end encryption or data residency controls. We work on our platform to secure your workloads, and then you have to work as well to secure your workloads. We'll talk through that. And things around identity protection, threat detection, and compliance and regulatory requirements as well that we know you have to deal with. So what we're going to cover is how do we think about each of these layers moving forward. But before I do get into this, let me talk about our Secure Futures initiative, the SFI work that you may have heard about. SFI, or Secure Future Initiative, guides us at Microsoft. It's a company-wide commitment. This is something we've been doing for a few years. And this is one of those where if you have a P0 issue, you drop everything and work on fixing the security issue. This is something that we've done very strategically over the years to ensure that we are increasing and strengthening the strength of our Azure platform. These are not just internal improvements. Things that we do internally also help you secure your workloads. Our goal is very simple with SFI. It is to help you operate with confidence, that knowing that your workloads are secure and safe. Now, one of the things, it's a call to action to you. We have learned a lot from enabling SFI at Microsoft. So this is something we call on you as well to start or thinking about these initiatives for a Secure Future initiative for your company. Because as you can see here, we go completely left to right. It's about secure by default, secure by design, secure operations, and it's across the stack. So the first thing we do, for example, is we protect our identities and secrets. We've talked publicly about how we have moved our Entra ID stack into confidential computing. We protect our tenants, we protect our networks, we protect our engineering systems. These are very, very targeted look into our own security systems to make sure that what we enable for you is fully secure. And it is continuous improvement, I think. That's the important part of it. Now, let's talk about what we get visibility into, right? As Microsoft, we run a ton of workloads. We get deep, deep visibility into the threat landscape with emerging threat actors, adversary behaviors. So just to say some numbers, we have 100 trillion signals that we get every day. We are looking at 5 billion emails to analyze sort of what's going on. We have identified 1.5 thousand unique threat actors that we track with our Mystic team, the Microsoft Threat Intelligence team. And the point of this is, we deeply, deeply look into what data we have available and use that to ensure your workloads, your digital estate is secure. But then that's the work that we do, right? We are detecting threat actors. We are detecting signals. But even with strong detection, threats will happen. The question is really, how fast you can detect and how fast you can contain them before the damage occurs. Now, these threats happen within minutes, not hours, right? These happen really quickly. So manual response just isn't enough today. AI-driven attacks, automated lateral movements that we see, they really need, in this day and age, automation, right? So the first thing is, I think before I get into this, what are the challenges? I think that's also important to call out. The challenges that we see is your digital estate is fragmented, right? If you show alerts, they get slow responses. You have limited visibility across your hybrid, across your landscape. So the things that we recommend doing is threat detection and response, right? Correlate signals that are coming through and make sure that you have unified data visibility across your landscape, across your workloads. Data and automation. AI can help a ton here. You can use AI-driven analytics and automation to triage, to investigate, and quickly respond to actors. As I mentioned, these attacks happen often in minutes. You don't have that much time. So you need to use automation to get there. And of course, the other thing is constant risk assessment. Where is your risk portfolio? What are you trying to do? Are you still exposed? Doing this constantly and iteratively is really important to ensure that you yourself can also detect these threat actors. The other thing is security is not just about stopping attacks, right? It's about proving trust. You have to prove that, with compliance needs, organizations are facing large, growing regulatory demands and data sovereignty requirements. And what you need to do is you need to enable governance at scale. Manual compliance just can't keep up with the speed of regulations that are moving around and the kinds of workloads that we are running today. So what we do with Azure is we provide a framework for scalable cloud control, helping you meet your global standards, global compliance needs, things such as certifications and standards, policy management and automation to make sure your policies are in place and you are able to detect in case there is drift, for example. And digital sovereignty is something that we see quite a lot because this helps you ensure data residency and sovereignty requirements are met across your productivity workloads, your security and cloud critical workloads. So why does it matter? Why does compliance matter? Why does governance matter? Because it is foundational for trust and business continuity. This is something that you should be thinking about if you're not already. So before we get into each of these individual areas, it's important to talk about the most critical aspect of your security workloads, which is your keys. And in Azure, we provide multiple key management options that I'll talk through. And what you have here is you have control over your keys and data in the cloud. And let me talk about the first one, which is the Azure Key Vault Premium. Your customer keys are available in a highly available environment in a multi-tenant HSMs. And this is something that everyone uses already, right? Like using an AKV Premium helps you manage your keys with your customer managed keys. And the next thing I'll talk about is Azure Key Management with Managed HSM. So AKV Managed HSM is something that we've built to run inside a confidential enclave. So your keys are just not visible to us. They are protected by enclaves. You have policy level control. You own the entire HSM. And this is the most secure key management solution that exists today. The other thing that we also hear is because of data residency, sovereign requirements, we have heard quite a lot about the need for an external key manager. So this is something that we are working on, which will give you external key management. With external key management, your keys are stored in your ownership. But there, the risk is that we don't provide any availability SLA because there are resiliency risks that you need to manage. But at least in that case, if this is something that your compliance needs then this is also an option for you. So the way to think about it is, if you're comfortable in a multi-tenant environment, using AKV Premium is just great. It's a very, very secure solution. And then if you want a higher level of protection where you want to own the entire HSM, it's a single tenant HSM and backed by confidential computing. So you can use Azure Integrated Managed HSM, and you can use external key management if that is something that you need. But you need to be cognizant of which of these layers give you what capabilities. So now let's dive into the first of the three areas, which is Azure Compute Security. So why does it matter, right? Workloads are dynamic. They scale up, they scale down, they move across regions. With AI agents, the world is kind of new. So this kind of introduces risks, misconfiguration, unpatched software, exposed secrets, right? So the challenges that we have are, inconsistent isolation, for example, drift from secure baselines as after deployment, as the product evolves. There are runtime threats that you need to be protected about, to be thinking about. So the way we think about it is in two layers. One is isolating your workloads from the cloud and isolating your tenant from other tenants on the same node. So think about this as a two-way tenant boundary. So the guest to host is protected and the host to guest is protected. So when we talk about the cloud provider isolation, we have done a ton of innovations, and these are just a few that will fit in a slide. You may have heard of Azure Boost, and I'll have a slide after this. Azure Boost provides hardware acceleration, but it also provides isolation. Azure Integrated HSM is innovation that we've done in Azure. It's a on-node key cache. It's a full HSM 140-3 HSM, FIPS 140-3 key cache, where all your crypto operations happen inside that HSM. The other thing is we've always been talking about Calyptra open source root of trust, and also something that we are pioneering, which is Azure Confidential Computing. And on the right, from the tenant isolation point of view, trusted launch, use it by default. You get secured boot, measured boot, VTPM, protection from rootkits and bootkits, multiple disk encryption and key encryption possibilities, patch and baseline hardening, just-in-time access. These are just some of the things that you can do as well to further secure your workloads. And many of these are enabled by default. So let's talk about sort of what is enabled for all, what are the things that you can opt in and configure. So as I mentioned, enable for all, the work that we're doing on Boost, the hardware root of trust, patch and baseline hardening. And then for your IaaS security, things like trusted launch, just-in-time VM access. But there are other things that you can opt in and configure as well. So the thing that I talked about with Azure Integrated HSM, that is in public preview right now, and that's something that you have to opt in and use. There are different HSM offerings that you can use. And with the advancement and the pioneering work that we are doing in confidential computing, we have different offerings around enabling confidential virtual machines and containers that I'll talk about, attestation and key management. But with confidential computing, what you get is end-to-end encryption. So let's dive into a couple of these. So the first thing I'll talk about is the Azure Boost DPU. And Azure Boost is, it's available in every server that we ship now. It's a hardware rooted attestation that you get at every server restart. It ensures that we are starting your server in a verified, attested state. And as customers, you get cryptographic proof about it. And it gives you hardware infra isolation. For example, we are running agents, et cetera, inside the Azure Boost DPU. And we have multiple security assurance work that we've done here around anomaly and baseline detection. The other thing that I'll talk about in a minute is what we are doing with Boost on confidential computing. So as a show of hands, how many folks have heard about confidential computing? Quite a lot. So confidential computing is a new technology that Azure has been pioneering for multiple years. It's about protecting data in use. So what does that mean, right? This is a standard picture. You have a client accessing an application, getting access to a storage. So data in transit, we protect that today. We've already done that, right? The industry has solved it. There's no HTTP, it's HTTPS, it's TLS. Data at rest, we've done that as an industry. We've protected that. We've solved it. But protecting data in use, when it is sitting in memory, is not something that we've solved as an industry at scale. And this is what confidential computing enables. It gives you a verified, a tested hardware root of trust that gives you assurance on that you're running in a trusted execution environment that gives you data and code integrity and data confidentiality. This is something that we have been pioneering, as I mentioned. This is something that we are rolling out for our security critical TCB services. For example, at the start, I had mentioned the Entra ID stack runs on it. Many of our security critical services run on it. But it is also something that is not meant for every workload yet. It is something that, if you have security critical workloads, you may have a performance overhead, at least in this generation, and in future generations, the performance overhead will come down and be at parity. And that's why I want to talk to you about the Azure Boost Confidential Device, ABCD. This is something that we announced at Ignite, which gives you, today what happens is because as we have to encrypt the data, the I/O that's going in and out of the guest boundary, and that adds the bounce buffering overhead, which causes the extra CPU cycles that you have to spend for an I/O or CPU-intensive workload. But with ABCD, Azure Boost Confidential Device, you now have encrypted I/O going in and out of the guest boundary. So now, this is the work that we've announced, and it'll come in future generations. But that will now get you performance which is almost at parity, or if at parity, with a non-confidential workload. So this is something that we have been working on for a long time. HTTPS took 15 years to become an industry standard. Confidential computing also is, hopefully in the near future, will become a standard, but it will take time. This is not something that gets done overnight. So as I mentioned, we've been working on this for a while. We started the infra layer. We've been working with Azure, with AMD, Intel, NVIDIA, ARM64, to ensure that every future chip has confidential computing capabilities enabled in it. So we provide virtual machines. We provide containers, integration with Azure Kubernetes Service. We have serverless with confidential ACI and virtual node 2. And then we also make our services confidential as well. So at Ignite, we announced Azure Postgres, which is going to be confidential. We have Azure Databricks. We also have Azure ML confidential inferencing as a service. So we host your models in a H100 single GPU today. And that is running inside an Azure ML service backed by multiple security innovations that we've done in this space. So now that we have compute secured, let's talk about storage, right? In the end, it's all about storage, right? Like, data is the ultimate target for these attackers. We know these breaches expose critical, sensitive information. They disrupt operations. And the challenges that we've seen in this space are around misconfigured access control, or overprivileged access to data. We've also seen customers coming in and telling us that data residency and sovereignty requirements to meet the regulatory needs of the environments that they're operating in. And the other challenge is AI is posing additional threats for data privacy and leakage, especially the leakage part. So what could you do? You can add controls, right, for data access. Apply least privilege to protect your sensitive data. Safeguard your data in transit. Make sure that you're using HTTPS, TLS, mutually attested TLS. Encrypt your data at rest. Ensure that data is fully encrypted. And respect the data residency and compliance requirements by ensuring that data stays in the required regions. And the other thing is for cyber resilience, right? Like, you need a greater defense against ransomware and malware activities that we see. So what can you use? It's around access control, encryption, and residency, right? So from a controls point of view, you can use Microsoft Entra ID with RBAC and ABAC, role-based and attributes-based access control. For fine-grained control over where your data is, what you're trying to do. Network access and encryption using private endpoints, NSP, encryption and at rest and by default. Flexible key management. And then for data residency and cyber resilience, using things like immutable storage, write once, read many, warm, to prevent against, so you have immutable storage essentially, and using vaulted backups. And then constant threat monitoring, right? Using Defender for storage for AI-driven anomaly detection. As you can see here, as well with previous section, it's all about introducing layers between you and the malicious actor. So let's talk about Microsoft Defender for storage. How do you start secure? How do you stay secure? So Defender for storage is designed to help you safeguard your data across Azure, AWS, GCP, wherever your data might reside. This solution starts first with ensuring and strengthening your security posture. It finds, it prioritizes, and fixes risks like misconfigurations, excessive access control that you may have given. All of this with one-click enablement. And on the threat protection side, detecting and responding to data threats is something that you need to do with Defender XDR. You have file-level access security. So what you have with Defender for storage is proactive risk management. You can ensure that you're not only, as you start, you're looking through your entire landscape, and over time, you're staying secure within the policy environment that you've set up. So here what you see is an end-to-end access control, right? There are multiple things that you can do, and what you choose obviously depends upon your threat vector, what you're trying to protect. Some workloads are way more critical. You probably need to look and think through every possible combination. But things around, what we are trying to do is give you that end-to-end comprehensive security. So things like Microsoft Entra ID that I mentioned with RBAC, ABAC, Azure Key Vault, ensuring that only authorized users, things like Azure Integrated HSM, Managed HSM, or here, across the board, there are different solutions that you can use to control your data access, encrypt data in transit, protected storage, ensure you have compliance and security features accounted for, and continuous AI monitoring. These are different capabilities that you can configure to get started. So with that, let me call on Mario Lopez. He's going to walk us through Azure networking.
Thank you, Vikas. Yeah, it's amazing to see all the great innovation in terms of securing compute and storage as well. Now, my turn is to walk you through network security. And I have to admit, I'm biased. This is probably, for me, the best layer of security that you can add. But of course, I'm biased. I work in network security. The scenario that I want to walk you through is what happens if you apply all of these best practices into your cloud workloads, and you have them with the least privileged access. They have very minimum access from your secrets, and data is encrypted. Everything is super, super locked down. But you still have an environment where everything is exposed to the internet. It's fully open. Everything has no restrictions whatsoever. And you're not adding any layer of security with respect to network conditions and isolation for your workloads. Well, if you're in one of those situations, the level of risk that you have for your workloads, it's pretty much you're at the highest level. The reason being, you're at the mercy of one small mistake in your environment. One credential leak, one secret compromise, a certificate accidentally published in a repo, in a documentation page, anywhere, or even a rogue employee or someone who is trying to take advantage of the access that they have within the company is good enough to compromise your data, your applications, or even worse, steal all of the critical information that you're hosting, maybe from your customers, sensitive information that it's critical for your workloads. So definitely adding network security as a layer of defense into your overall stack is one of the most key elements that you would have to apply in order to isolate from those type of threats. And I'll start describing a few of the areas of considerations that everyone should follow in terms of best practices. The first one that I liked personally to start with is isolation. And this one starts with basically creating a secure boundary and environment for your applications and workloads to operate and communicate within each other, having an isolated network, and eliminating completely all exposure to any untrusted network. Untrusted networks, the primary one, public internet. If you accomplish your applications to be completely isolated in the cloud, you would be at a much better state by eliminating maybe 99% of the threats that are out there by reducing all of the risk of anyone trying to compromise your applications. So definitely the first best practice that everyone should try to follow is keeping your applications isolated from any untrusted network, starting from the internet and also within your own workloads. The second one that goes along with this is segmentation. Anything that you have within your networks, within your trust environments, if you can create layers of access between your workloads, you would have prevented any threat, lateral movement from anyone compromising any of your workloads. If someone has access to one of your tiers, maybe one of your systems, or maybe one of your environments, it will eliminate the risk of those attackers to gain access to other systems, other environments, maybe going from dev to prod, and so on. So you will basically create a lot of friction for whoever is trying to gain advantage of the access that they have into your environment. Once they are inside, they will find it very difficult to move laterally if you're applying the right amount of segmentations within your network. And at the top of this, I have what I would call the threat mitigation, which is if you absolutely need to be exposed to the internet because maybe you're serving some website to your customers, or you have some interactions with other service providers, or you need to be exposing your services in a front-end interface to any consumer that could be in any network. At that point, the best practice that you could follow is how do I reduce the levels of access and exposures that they have on me by ensuring that the surface area that you're exposing to them has enough protections to limit anyone trying to compromise your systems or even trying to compromise the availability of your systems by poking into those endpoints that you're giving them access to. Now, I'd like to then jump a little bit deeper now into a specific area, which is in relation with IaaS, which is about securing storage accounts. As you can imagine, this is a critical aspect in terms of risk for your deployments in the cloud. The reason being, and I think I classify this in two dimensions, it's not only bad to have any exposed workload to the internet if you don't need to. But secondly, and more importantly, if you're exposing a storage account, or maybe a SQL server, or maybe a keyboard, all of those are sensitive workloads that typically host your backend information. Your customer data might be there. Your critical business information might be there. So definitely exposing this type of endpoints to public and untrusted networks is a very bad practice in general. As Vikas was describing, within Microsoft, we've been following SFI, the Secure Future Initiative, to help us reduce and also standardize across all of our fleet in terms of following all of these best practices. This is one of those features and capabilities that we started using a lot inside, and we ended up announcing and releasing to public recently in GA, I think this last summer, with a lot of battle-tested scenarios within our own first-party services. We're using it with now more than 1 million storage accounts and keybolds and SQL servers. We're basically using the same standard and best practice inside, and in this case, particularly first inside and then outside exposed to third parties as well to gain exactly the same benefits. Now, what is the approach that we use with NSP? And the reasons maybe the main reason we started out with NSP for securing our own storage accounts and keybolds. The first one is it provides a unified firewall experience for all of those types of services. And the idea behind it is to keep expanding the supported number of services to cover something similar to what Private Link covers today, which is a large list of cloud services with the same standard firewall for all of them. It's a consistent experience, a consistent layer of definition where you can limit your exposure by explicitly adding rules that will define your levels of exposures for your access. At that point, you have basically a great tool for managing not only storage accounts, but also any other resource type. You don't have to deal with any variations, any inconsistencies in behavior. It's a single unified standard layer of control for that. Of course, second to this, it's integrated with Private Link and your VNet workloads. Everything that you have in your VNet that you have already gained access to those resources, it works nicely into it. It's a complementary control. This is limiting the public access while you can keep a private access from within your VNets as well. But in combination between those two, it gives you a good set of assets for describing what is considered to be your trusted networks that should be accessing your critical data and this types of resources as well. One of the elements of considerations as part of the design of this technology was to make sure that it works in a couple of scenarios. One, in a secure by default mode. And what I mean with that is you have the ability to deploy new storage accounts, new keybolds, new SQL servers, lockdown, without any access. And then you can describe what you really want to be open to and exposed to if you really have to be exposed to certain public IPs that are maybe descriptive of your on-prem environment, or service providers that are accessing your data that you would like to be exposed of. But you don't have to take any risk when you do that. Basically, you can start fresh with a lockdown environment and then slowly keep adding anything that you consider is valid without necessarily having to land in an environment where there's a lot of risk of exposure. So that's number one. The second one is what it's called transition mode, which is we understand the majority of customers will come with their own workloads that are already in the cloud. They are working, operating, and many times they might not have any restrictions on it. They might be fully exposed, and gaining visibility into the access or moving into a lockdown environment, it is extremely painful. This is what I like to call a retrofitting of network security. It's extremely painful. By the way, a good recommendation is if you can start new workloads, at least Greenfield scenarios, with a lockdown secure by default approach, you will gain a ton of benefits by not having to go through a very expensive journey of migrating existing workloads into a lockdown environment. The reason being is you have things that are working, and they might be running production workloads. Definitely, you don't want to mess stuff with firewalls, because the only thing you can do with a firewall is you can break it. If you don't know what you're doing, most likely you would start breaking production environments. So this mode that it is introduced here, it helps you with that journey. It's basically a journey of I'm moving my workloads. Maybe I don't have a good understanding of what is considered to be trusted yet. But I know connections are happening. I know it's actively used, especially in environments where there's already applications consuming these types of assets. Therefore, this mode gives you the ability to start enabling logs. And enabling logs, again, it's a standard unified experience. All of them will start emitting logs about all the connections that are happening. Any connections coming in to those resources will start emitting logs, connections coming out as well, or even interactions within those resources. All of those will generate a log. And the log will start to say, this access would not be approved by NSP. It would be approved based on the existing configuration of the resource. Therefore, please, before locking down the access, consider this and evaluate if it's an acceptable access. Now, this type of visibility, what it gives you as a user or consumer of this is, it gives you, number one, safety. You're not moving into a state where things are locked down and things are starting to break. There's nothing in transition mode that will break. Things will continue to work as they are working right now. But second, it gives you data-driven decisions. You can take a look at the logs. You can gain visibility into what's going on with your workloads. And then you can formulate the right amount of rules that you consider are valid to limit the access to finally move into a lockdown enforce mode where you're eliminating all of your levels of exposures within your workloads. So definitely it's a great tool for not only Greenfield, but also Brownfield to make sure that you're moving your workloads safely from any of those states that you have new ones or Brownfield deployments in a more restricted environment. Like I said at the beginning, securing this type of assets, it's probably one of the #1 things that everyone should do, which is eliminating all of the risk from any malicious actors from outside, and also eliminating risks from anything that could happen within your own networks as well. Now, I'll zoom out a little bit now to describe roughly in different areas of the cloud, the different set of options that we have, depending on the landscape of mitigations that you're trying to look. On the left, we have observability. There's a bunch of tools related to adding visibility and governance around your networks. We have Sentinel Traffic Analytics. We have Network Watcher. We have integrations of Sentinel with Azure Policy to even give you best practices and governance aspects into all of your deployments as well, to ensure that you're limiting their blast radius and with a set of recommendations that will help you to narrow down everything that it is happening within your networks as well. With respect to exposing to the internet, of course, we have methods to expose to the internet. You can start with a public IP. You can start with an app gateway with Azure Front Door. You can also expose some workloads through firewall as well. All of those, there's a collection of tools and features that I'll describe in the next slide about mitigating the threats that could come out from any public network. From within your private networks, we have VNets, and now we have NSP, which is two complementary solutions for adding IaaS compute workloads where you can basically grow your ecosystem of solutions as well and define all of your applications in traditional IaaS, but at the same time with NSP, you're complementing by combining now storage, Key Vault, SQL, and all of the past solutions, managed solutions where you can combine all of them, again, with a similar level of control where you're limiting access from public internet and you're connecting your applications together. If you need to connect to on-prem as well, we have a good collection of resources and assets as well, like ExpressRoute, VPN Gateway, we have V1, and also you can use third-party MBAs as well, where it'll give you basically a private channel and connectivity from your on-premises, again, with the aim of isolating your on-premises from any internet exposure and isolating as well all of your cloud workloads from any of those connectivities that you might need. And in terms of segmentation, firewall bastion, we have NSGs, ASGs, a lot of great toolings for creating different layers of customizations within your network to ensure you're minimizing the exposure of anyone attempting to do lateral movements. Now, going a little bit deeper now into if you're exposing your workloads to the internet and you really have to expose APIs and web servers to consumers, your inbound interface, which is what I have here on your right side, definitely will benefit from applying a couple of good practices and technologies into it. DDoS is #1. DDoS, it has a basic offering that everyone gets for free. You don't have to activate it. It's enabled. Basic is enabled for everyone. We use it within our own assets as well. And then we have standard SKU as well. And they come with a great level of customizations. You can apply it entirely to your whole VNet. You can also go selectively on a per public IP to make sure that you're improving your thresholds in terms of how much you're exposed to DDoS attacks and what kind of levels of protections you want to achieve. Behind the scenes, behind DDoS protection, what happens is we have a shared platform that it is capable of handling all of those attacks that would normally go and hit CPUs from your compute workloads. All of those will basically be offloaded to our platform to ensure that we are reducing the load and the heat into your consumption as well. Similarly, if you're exposing APIs and you have a good number of developers that are creating web servers and applications that are into traditional HTTP, HTTPS, you can expose those globally with front door or locally in a regional deployment with App Gateway. And in both cases, you can apply a good set of best practices and layers of filterings with WAF, which gives you a nice cocktail of filtering for any of those API calls before hitting any of your backend systems. You can have the confidence that you're not exposed to traditional, very well-known types of attacks, like maybe a cross-site script injection, SQL injections, things like that are basically going to compromise your backend service. Any mistake done by your developers, it's also bulletproof with this type of technologies. You're basically gaining advantage of a good, well-known set of filterings before it hits any of your backend applications. On the outbound side, one of the best options that you could use is the use of an Azure firewall. Again, it comes with different set of offerings, going from basic to premium SKUs. If you start with basic and you start to eliminate any outbound access to any destination that it is not designed for your applications, you will gain tremendous amount of value for your applications. The main reason for using an egress stack, a security egress stack like Azure Firewall, would be to prevent any workload within your private and isolated environments to steal data and push it out to any untrusted destination. You would basically prevent anyone from, once they are inside, to take advantage of those types of workloads by filtering that access and making sure that it is going to exact destinations. On top of that, there's a lot of threat intel, IPAs, IDPS, that would basically give you additional layers of protections for common, well-known types of threats as well. Just to zoom out a little bit, this is just a comprehensive list of all the products and features. I did my best to jump into a couple of areas and deep dive into a few, but definitely there's a lot of areas of good practices that you can apply in terms of network security across the board. One of the best ones that I would recommend everyone to try it on is Azure Bastion. We have now a new developer SKU that gives you access, an RDP access to your VMs and workstations without having to expose any of your compute workloads at all. Last but not least, we have a few set of resources that are going to be shared for the presentation as well. And of course, as always, yeah, we appreciate all the feedback and guidance in terms of the session. This is the QR code. Appreciate all the guidance and feedback here as well. Yeah, and last but not least, it's a Friday session, and the last one. Appreciate everyone joining us here in the session as well.
Thanks, everyone.
Thanks, everyone.